The design and modification in the hydraulic system. Kitamura machine works with the basis of hydraulic system. It consists of two power packs. Each power pack will generate up to a precious power. One is for the variable the gear tool with alternating tool part. Another work power is one bar for the clamping the tool. For the clamping the tool, 50 bar pressure is required, and the fixture's 40 bar pressure is required. For the clamping power pack run with just 20% of efficiency. Other with runs with 60% of efficiency. The aspect of the project is that the machine which is operation with the two power packs, that the machine should be run with the one specified power pack. It's the objective to create the most proficient hydraulic machine is the power expenditure, consume less operational area and reduce the outlay of the system. The problem identification in the hydraulic system. The power pack does not consist of oil indicators and no oil gellers to be power pack. When using of two power pack, wastage of hydraulic oil, wastage of electricity cost, wastage of an hydraulic motor. These are the two power packs which is we are using for the Kitamura machines. When we are using of these two power packs, these are the two hydraulic motors, and then there is no oil chillers and the two wastage of an hydraulic oil. Actually, the hydraulic system in the industry, it consists of holding device and operational device. Holding device, it is a tool in the hydraulic system which does up to 20% of the total load. The function of the holding device is to hold the tool in the required direction and the position according to the operation. Operating device. The operation device consists of the different tools for the different operations. This device will carry up to the 80% of efficiency. What we observed in the industry for the both devices using a lubricant which is the high cost. Due to the working automatically, the device and the lubricant will be heated. The no indication for the lubricating level. The compressor is the important device which should maintain 50 pascals of the pressure of the operations. It occupies the most space other than the systems. It consumes electricity is also high. Actually, what we have designed in the CATIA when they are of two power packs. The manifold, the manifold. The hydraulic manifold is the component regulates the fluid flow between the pumps and actuators and the other components in the hydraulic system. It could be compared to the switchboard in the electrical circuit. Hydraulic manifold is the component that regulates the fluid flow between the pumps and actuators, the other components in the hydraulic system. It could be compared to the switchboard in the electricity because it is an electric operation control that much the fluid flow between the components of the hydraulic machinery. For the example, in the backhoe header, the manifold turns to the stance of the flow. The telescopic arms of the front pocket of the back bucket of the manifold is connected to the level in the operational cabin, which is the operator uses to achieve the desirable behavior. The types of manifolds: directional control, flow control, and the check valve and the pressure relief valve. The pressure control flow. The advantages of the control flow is the most effective and the control the velocity. Here we are using the D5 size of the flow control manifolds. Check valve. The advantages is the increase the machine safety and the wide ranges of product. Here also we are using the D05 size. The two-way slip in the cat trap. Directional control valve. The directional control valve manifold will be the extremely broad selection of the value configurations of a futures and higher flow rates of an increase in a positional speed, and the faster valve responsible for the control, and the pressure relief valve, the system protection, and against the excessive pressures, eliminations of a hazardous pressure flow. The effect of the control pressure, which is the switching functions, only self-constant pressure and the flow control, both the port pressure and the electronic. Actually, what we have designed in the CATIA when we are using to the single power pack. The above images shows our design concept. Modification done itself. We arranged the two devices holding and operation in the same equipment, which reduces the occupying area and the hydraulic system. The consumption of the lubricant will be less when compared to the two devices, saving the electricity. High efficiency is the single operation device, which does not have an overheated, and so work efficiency will be high. We arranged the pressure gauge and the sensor to the compressors. The pressure gauge is used to maintain the 50 pascals of pressure for the good performance. The sensor is attached to the gauge to maintain the required pressure. Due to the sensor, if any changes in the pressure, it will be the sound alerts to the operator. It avoids the system damage because if the level decreases, we will fill. We arranged the air cooler for the lubricant, which is to cool down from the cool down the air. No need of no need of external equipment, no need of electricity. After designing of a single power pack, the oil tank capacity is 80 liters and the Indian type of oil 32, and 1 liter is equal to 1 liter is 36 rupees. We can save 2,800 rupees, 2,800 rupees for 15 days. Per annum we can save 9 floor area. The length will be 60 centimeters and the height will be 21 and the breadth will be 45. Totally overall space between the two power packs is 4.8. When we reduce to single power pack 2.6 square feet, we can save electricity. 1 kilowatt, 1000 kilowatts is equal to 1 unit. Hydraulic motor is 1500 kilowatts per hour. 1 unit is equal to 8 rupees. So we can save 1,05,120 rupees per annum. When we are using of two power packs, cost will be the hydraulic oil cost is 1,38,240 rupees per annum. Electricity cost is 2,10,240 rupees per annum. So we can save 1,74,240 rupees per annum when we are using a single power pack to control the Kitomura machine. This is the single power pack which we connected to the Kitomura machines. It having an oil indicators and oil chillers, pressure gauge, and single motor. That the tank is increased to 90 liters. The conclusion: the aspect of the project is that which is the operation with the two power packs, that the machine should be run with the only single power pack. In this progression, we have measured the expenditure of the hydraulic motor, hydraulic oil. We can condense the floor area as well as the electricity expenditure. Consuming the power pack is used to the overall efficiency only for the single power pack used to the variable gap, the tool bit alternating tool part, and consuming this power pack will be used for 100% efficiency. Thank you.